All right, let's get you prepped for that SDE2 interview. Today, we're not just learning some new technique, we're going to master a mindset, a way of thinking that really separates a good answer from a great one. We're going to crack the code on a really powerful optimization pattern called carry forward.
So here's our game plan for today. First, we're going to tackle the problem everyone runs into, that classic clunky nested loop. Then, we'll get to that aha moment with a carry forward insight. And we're going to level it up, talking about space complexity and even some advanced variations. Finally, I'll give you the exact game plan you need to walk in there and totally impress your interviewer. Let's do this.
Okay, so let's kick things off with something we have all written probably in our first programming class, right? You get a problem, and the first instinct is just compare every single element with every other element. And look, it works. You get the right answer. But in an interview? Oh man, it is a performance disaster just waiting to happen.
And here it is, the beast itself, the dreaded O of n squared nested loop. You know, O of n squared. That just means if your input size doubles, the amount of work your code has to do quadruples. It gets out of hand fast. Just look at that code. For every single element I, we're firing up another loop and rescanning a huge part of the array. Imagine an array with 1 million items. This thing just completely falls on its face. An interviewer expects you to spot this from a mile away.
This right here, this is the absolute heart of the problem. This is the phrase you need to burn into your brain. We are doing the same work over and over. That's it. When we move to the next element, we just forget everything we just learned. And that redundancy, that's the weakness that this whole carry-forward technique is designed to just completely destroy.
So, how do we fix it? Well, this is the really cool part. Instead of constantly looking back over our shoulder, we're going to learn how to remember the important stuff and, you guessed it, carry it forward with us.
The core idea is actually super simple. You just make one single pass through the array, and as you go, you keep one variable updated. That's it. This one variable acts like your short-term memory, holding the summary of everything you've seen so far. And that one little variable completely gets rid of the need for that second nested loop. Think about it like this. Say you're collecting rocks. The brute force way, the hard way, is every time you find a new rock, you run all the way back to the beginning to compare it with every single rock you've already seen. Sounds exhausting, right? The easy way, the carry-forward way, is to just keep a little note in your pocket that says, biggest rock so far. Now you only have to compare a new rock with that one note. Simple, fast, and way more efficient. And this slide shows it perfectly in action. Let's say we're counting AG pairs in a string. Instead of finding an A and then rescanning the rest of the string for Gs, we just iterate once. We carry forward a count of the A's we've seen so far, so the moment we hit a G, we instantly know how many pairs it forms just by looking at our count A variable. This takes us from that clunky O of n squared down to a beautiful, clean, linear O of n.
Okay, now we get to the part that really separates a junior dev from a mid-level engineer. This is the SDE2 level up. It's not just about making the code faster, it's about being smarter with memory. And this is the goal, O of 1, constant space complexity. What that means is we want to solve the problem without creating new arrays or lists that grow with the input. We want to use just a handful of variables, whether the input has 10 elements or 10 million. So here's the crucial distinction. A pretty common approach is to pre-calculate values in what's called a prefix array. And yeah, that works. It gets you O(n) time, but it costs you O(n) in space. A senior engineer looks at that and asks, wait a minute, do I really need to store everything, or do I just need the summary? Realizing you can replace an entire array with one single variable is a massive insight. It shows real maturity and a much deeper understanding of efficiency.
All right, but what happens when the problem is a bit more complex? What if you need to know stuff not just from the past, but also from the future? Sometimes one pass through the array just isn't going to cut it.
And the solution is actually pretty elegant. You just apply the carry-forward technique twice. First, you loop from left to right, calculating and storing some kind of state based on everything that came before. Then, you do it again, but this time from right to left, carrying forward a different piece of information. By the time you're done, every element in your array has the context it needs from both sides.
And this isn't some weird, obscure trick. It's the key to solving some of the most famous, high-frequency interview problems out there. For a problem like trapping rainwater, you absolutely need to know the max height to the left and the max height to the right. And for product of array except self, you need the product of everything to the left and everything to the right. Both of these are just perfect use cases for the two-pass carry forward.
Let's just look at this table for a second.
It's basically your study guide right here. You see this pattern everywhere. For best time to buy and sell stock, a super common one, you just carry the minimum price so far. For leaders in an array, you do the same thing but backwards. You carry the maximum from the right. It's the same core idea, just applied in slightly different ways. You got to master the pattern, not just memorize the problem.
So, you've got the technical solution down. Great. Now, how do you actually talk about it in a way that signals experience and competence? Let's put together your interview game plan.
And remember this, the interview isn't just a test of your code, it's a test of your thinking. Seriously. The way you arrive at the solution, how you explain the trade-offs, how you articulate the optimization, that stuff is just as important, if not more important, than the final lines of code you write. So here it is, your 4-step playbook. Step 1. Always start with the simple, brute force O(n)² solution. This shows you understand the problem at its core. Step 2. Immediately call out its weakness. Use the magic words, "We are recalculating redundant information." Step 3. Propose the carry-forward technique as the elegant, optimized solution. And finally, Step 4. Confidently state the final time and space complexity. This shows a complete professional thought process from start to finish.
And here it is. This is your money line. The single sentence tells the interviewer everything they need to know. This approach reduces the time complexity to O of n and, crucially, keeps space complexity at O of 1. That one word, crucially. It signals that you get it. You understand that keeping space constant is a huge engineering win.
So, as you're practicing, don't just solve problems to get a green check mark. Start looking for the underlying patterns. The next time you see a problem that asks you to look at previous or future elements, ask yourself this: what single piece of information, if I just carried it with me, would solve everything?